Students, this time I'll be dealing with the subject called analog communication for you people. Before we start with the actual syllabus, let me introduce the overall view of this subject. Now, the overall view of this subject is this is analog communication with the code 15 EC 33T. This analog communication actually it has got two parts in it. One is the electrical circuit. You will be knowing about the electrical circuits. Next comes the analog communication part. Though the name of your subject is analog communication, in this you will be studying first part as the electrical circuits. You will be knowing about the behavior of the electrical circuits, then you will coming for the study of analog communication. So these electrical circuits, they are under unit 1 and unit 2. Unit 1 and unit 2 teaches you about the electrical circuits, whereas unit 3, 4, 5th and 6th are completely based on analog communication part. So here coming to this unit 1. In unit 1, what do you have is, you will be knowing what is electrical circuit and the definition of a network or electrical circuit and some theorems concerned with the electrical circuit. So these theorems teach you to find the different ways of finding the voltage or currents in a given electrical circuit. Next is unit 2, in which you will be knowing something about the electrical circuits, like what do we mean by resonance of an electrical circuit, what do you mean by filters. Filter is nothing but it is also an electrical circuit. What is this filter, what is attenuator, their different types, design equations, so many things you are going to study about resonance, filters, attenuators under the unit 2. So unit 1 and unit 2 are concerned with electrical circuits. Then comes the unit 3, which is a part of analog communication. You will be studying about some of the transmission lines. So what is communication? Communication is nothing but a transfer of information from one place to another place, or you can take it as sending and receiving of information from one place to another place is communication. For sending that information from one place to another place, we need transmission lines, the lines through which we can transmit our information. So you will be studying number of transmission lines and their types here. Then comes under unit 4, you will be knowing about antennas and wave propagation. Antenna, it is also a transmission media. Through antenna, we will be transmitting EM waves from one place to another place, from transmitting antenna to the receiving antenna. So such antenna which we are using for a transmission of EM signals, how many types of antennas are there? Their structure, their working, we will be studying under this. Then wave propagation, different modes in which the wave or the signal what we transmit from one place to another place is going to propagate, that you are going to study. So now you may not get a clear idea about this wave propagation and all in this class, but as we proceed further you will understand. This is just the overall view of the subject. In the unit 5th and unit 6th, you will be studying about modulation. Here I have written AM and FM. AM is amplitude modulation, whereas FM is frequency modulation. So modulation is an important process which takes place in the communication system. There are different types of modulations. Here only two types you have, amplitude modulation and frequency modulation. When we go for modulation at the transmitter level, at the receiver level, we have to go for demodulation. So AM modulation, demodulation, FM modulation, demodulation, different derivations are there, problems are there on this, that you are going to study under these two units. So once again, analog communication is the second part of the syllabus. First part of the syllabus is electrical circuits. With this, what I have thought is I will be starting with unit 2, because unit 1 there are many problems. You may face some difficulties in understanding the theorems as we start now. So what I thought is, first I will make you understand about the electrical circuit, like what do you mean by resonance of a circuit, what do you mean by filter, attenuators and all. Then we will be moving into this. So first, taking up this, I will be starting with unit 2, that is resonance. So in this class, I will tell you what is resonance here. Just see, resonance, filters and attenuators, this is unit 2. Before we go for the resonance definition, we will take up one example and we will try to explain you what is resonance. See, here is one circuit. I have applied some input signal, and out of this circuit I will be expecting some output signal. So this is input signal and this is output signal. I have shown you the signal is AC here, input signal, and I have written F with the arrow mark. That means frequency of this signal I can vary. Now the frequency of the input signal can be varied, I have told. I will vary it to a frequency F1. Let's go for the different frequencies like F1, F2, F3, F4 and all. So at the frequency F1, I will be getting some output signal here. At the next frequency F2, from F1 to F2, I will change the frequency. If you check the output is somewhat increased than the previous frequency. Check for the next frequency F3, still there is increase in the output signal. If you go for F4, there is again increase in the output signal. But if you check for the next frequency F5, you will find that there is decrease in the output signal. It is not now increasing after F4. It is decreasing at F5. So whatever response of the signal, what you are getting at the output circuit is the maximum increased output signal that you are getting at the frequency F4, because at F5 the output signal was decreasing. So at F4 you got the good response from the circuit. F6 you check, it is still decreased. F7 still decreased. F8 still decreased. So what is the frequency at which you got good response from the circuit? That was the frequency F4. So now what we say is, at F4 the circuit has achieved resonance. I will repeat, what we say, at frequency F4 the circuit has achieved resonance. That means resonance is the phenomenon of the electrical circuit in which the circuit provides the good response for a particular frequency. What it is? Phenomenon of the circuit in which the circuit gives good response at its output for a particular frequency. That is called resonance. And that particular frequency at which the resonance is achieved, that we call it as a resonant frequency. So here is the definition. What is resonance? It is the phenomenon in which the circuit that at a particular frequency the response of the circuit will be very high or very good. And what is resonant frequency? Resonant frequency is here the frequency at which circuit reaches resonance, or the particular frequency at which the output of the signal will be maximum. This is resonant frequency, and here I have shown at F4 it reaches maximum value. So F4 is the resonant frequency, and we say at this particular frequency the circuit has achieved resonance. So this is the meaning of resonance here. Next, we will see the types of resonant circuits. There are mainly two types, series resonant circuit and the parallel resonance circuit. So in the resonance circuit, there are only three simple passive components that we are going to use, R, L and C, across the AC source of variable frequency. Here also F I have written and the arrow mark I have shown. It means this is the input AC signal whose frequency I can vary. You can see R, L and C. They are connected in series across this AC source. This is series resonance circuit. So this R and L combination, you can call it as a coil. Coil is the inductor, R is its internal resistance. I can define what is series resonance circuit is the circuit in which coil and capacitor. Hope you understood what is coil. Coil and capacitor are connected in series with the AC source of variable frequency. This is series resonance circuit. Same thing about the parallel resonance circuit. What will you explain? Coil and capacitor are connected in parallel across the AC source of variable frequency. This is parallel resonant circuit. Hope you understood the difference between series resonant circuit and the parallel resonant circuit. Next, coming to the applications. Very important application of a resonant circuit is for tuning radio transmitters and receiver have used. I have written for tuning radio transmitters and receivers means while watching TV and all, we will be selecting a particular channel. We are selecting a particular channel means we will be selecting a particular frequency. Channel is depending on that particular frequency. When you tune your receiver or your instrument to a particular frequency, you will be getting the maximum output at that particular frequency. Therefore, in general, what we say main application of a resonant circuit is for tuning radio transmitters and receivers. Then it can be used to maintain the AC circuit oscillations at a constant frequency. We can see this resonance circuit is mainly depending on the frequency, that is a particular frequency at which the circuit response is going to be maximum. So we can use this in AC circuit to get a constant frequency oscillations. Similarly, this can be used as a filter circuit. Filter means to extract something out of something, that is filtration. So here to extract a particular frequency or a particular range of frequencies for a particular application, we can use this one as a filter also in terms of frequency. So these are the main three applications of resonance I have listed out here. So in this video, we saw at the overview of the syllabus, we came to know that there are two parts in the syllabus. One is electrical circuit, second one is analog communication. Now we have started with the electrical circuit, that is unit 2, in which you will be studying about the resonance, filters and attenuators. We have come to know what is the meaning of resonance, then the types of resonant circuit and its application. In the next video, we will be dealing in detail with this series resonant circuit. We will see some of the derivations here, main derivations and the derivations in the parallel resonant circuit. Thank you.